שמי יורם, אני מחברת דויט, ברוכים הבאים ל-The House of Untitled Chapter. אנחנו נעבור עוד מעט סשן עם מר דייב אליוט. לפני זה קצת על המקום, המקום שלנו בעצם לדויט, אנחנו יושבים פה למעלה, כל התבנה כמעט שלנו. דויט היא חברת שירותי מומחה, אנחנו מתמחים בעצם בכל מה שקשור בעננים או של אמזון או של גוגל, עוזרים לחברות, אם זה לעבור ואם זה בשימוש בטכנולוגיות מתקדמות שקיימות להם בעננים. שותף השנה של גוגל העולמית, שותף השנה הטכנולוגי 3 פעמים ב4 שנים האחרונות, מאוד גאים בזה. המקום הזה הוא, excuse my Hebrew by the way, we will switch to English in a few seconds. המקום הזה משמש בעיקר להעברה של ידע, גם שלנו אל הקהל וגם של הקהל אל הקהל. אז אם יש לכם איזשהו נושא שהוא מעניין, טכנולוגי, שיכול לתרום לקהילה, דברו איתנו, אנחנו נותנים את המקום בחינם, באמת הוא לשימוש של הקהילה, רק צריך לתאם איתנו, אם יש לכם הרצאה מעניינת או תחום שאתם רוצים להעביר, דברו איתנו, נסגור חלון זמן, נצלח את המקום ונעזור בכל מה שקשור מסביב. I would like to introduce Dave Elliott. This time I got it right.
Not the singer, guitar player.
No. Well, Dave usually is coming with a huge band,
Yeah.
so please.
All right, thank you. So I'm Dave Elliott with Google. Been with Google for about 5 years, and I don't have a presentation, but I'll talk about a little bit about AI and machine learning, and explain a little bit about how we think about it here at Google, and then be around to answer questions and do general meetup type things. So first, thank you for the invitation. This is terrific. I was speaking at a conference earlier today, hence sorry for the jacket. But the conference was called The Future of AI. And I guess I'll just walk through a little bit about sort of what I talked about in the conference and what I do at Google. So my focus is artificial intelligence. I work in the cloud group. So similar to what you find with Microsoft Azure or Amazon Web Services, or perhaps IBM, we have a public cloud offering. Our offering is differentiated in a few interesting ways, I think. One is in and around machine learning. So I will start with talking about how when I was young, I'm a nerd, an admitted nerd, and I wrote a baseball game, American baseball game, when I was 15 years old. And I spent about 6 months building this thing, and at the end I was pretty proud of it, really liked it, showed my friends, and it was a typical game where one user does this, throws the ball, and depending on how they hit the buttons, the ball performs some way, and then someone else has a bat and they swing and they try to hit the ball. Depending on when they hit the button, there's some result. My friends looked at it, they played it, and they said this is good, but it would be better if you had, say, if you took into account if it were raining outside. If it were raining outside, maybe the ball behaves differently. Or if it's cold, the ball might behave differently. Or perhaps the person who's pitching pitched the night before, so therefore he's tired. So I said, this is great, good feedback, and I went back and, like a good software developer, I went and made changes to my program, right? I added those additional variables over and over again as I got more and more feedback, and pretty much spent the next 2 years doing that. And that's pretty much how software has been developed for 40 plus years, right? If then else statements, while loops, basic objects, rules, and heuristics. And that's par for the course. That's normal way you've developed things. What's exciting about machine learning, what's different about machine learning, is that it can change the paradigm of how you develop software. Instead of creating those rules and having to go back and maintain all those rules, which is just labor-intensive work for a developer, you can now create a system. This is the vision and what we see as a reality at Google. You can create a system that learns itself from the environment, from the data that you feed it, from the examples that you give it, and that it improves the model over time without you having to do much of anything. And so that's what's exciting for a company like Google, where we have 7 product lines that have over 1 billion users. And the 7 product lines with over 1 billion users, each of them have this incredibly large code base that we need to maintain and improve and continue to hone. So things like search, right? You can imagine all the search rules we have to develop to be able to come up with the best results depending on your location, your search history, what's changing in the environment. It's just an infinite number of rules you need to build and develop. So that's the excitement, the interest in machine learning, is that it's a closed loop system that can improve itself. So that's why I'm excited about it. I think, first off, how many people here are developers, hopefully? All right, good group of people. All right, excellent. So I'll talk to you from a developer standpoint, so again, that's why I'm excited about it. And with 7 product lines and 1 billion users and millions of lines of code, it becomes a really, really exciting, interesting thing for us to be able to build better services by having these closed loop systems. So let me take a step back. Artificial intelligence is the big sort of bucket, and people use interchangeably AI and ML. And I think it's probably okay, but generally artificial intelligence is sort of the science of creating, well, intelligence that mimics a human, right, artificially. In that, one method to do that is machine learning. And machine learning is that closed loop system that I just described. Probably the hottest area is that people talk about today is deep learning in particular, with maybe creating a neural network. I could chat one-on-one with you, or I could talk more about that in detail, but that's sort of the hierarchy, I guess. You got artificial intelligence, machine learning, and then sort of deep learning, the big buzzwords right now in this space. What is machine learning? Machine learning, that closed loop system, is basically using examples to make predictions. I think it's maybe the simplest definition that I've heard, using examples to make predictions. So that's using data to find insights, or you may be using mathematics to derive those predictions or those insights. So it's data or examples, predictions, insights. When I talk about machine learning or AI, and I'll use those interchangeably, and I probably shouldn't, but I probably will. When I talk about machine learning, I usually get asked the same 3 or 4 basic questions I'll go over, now. One is why. What is machine learning? And I think I just explained that, right? Examples for predictions. Second thing is why now, right? There's so much hype associated. You can't, read anything online without hearing something about, machine learning, it does this or that, or the potential of machine learning, or breakthroughs. Why is Google and Amazon and Microsoft and Facebook and everybody putting such an effort in this? So the second thing is why now? What's happening now that's different? And then the third thing is why Google. So I'll kind of walk through those 3 things. Let's talk about why now. The promise of machine learning, right, the closed loop system gives you really good insight to make those predictions, is fantastic. The reality is it's been around for the concept has been around for 50 years or more. And what's changed in the last few years is 3 things. So the first is compute. So it turns out that doing this is really, really computationally intense, and it's also when you're talking about especially doing the training, it's a different type of math, right? It's matrix math, right? It's different than what you typically do if you were developing a software program that ran on a CPU. So first thing is compute. The cost of compute has gone down a ton, right? It's fallen to the floor. Moore's law, cost of compute going down, the concepts of cloud computing, right? You only pay for what you use. No need to build and manage your entire infrastructure yourself. The development of GPUs that originally were designed for graphics. It turns out that math is similar to what you do when you're developing machine learning models. And And then now the development of custom ASICs that are even more optimized, custom built hardware. In Google's world, it's TensorFlow processing units, we call it, TPUs. And in NVIDIA and now Amazon and others are also developing custom ASICs to specifically be optimized for doing this compute. And the reason that's important is because it's computationally intensive, and so the cost of doing the machine learning, the training in particular, was really, really high. That's fallen through the floor in the last 5 years or so. In the last 2 years, in the last 18 months, you've seen these dramatic drops. I work with a guy who's a PhD in machine learning. He worked for the National Weather Service in the late 90s. And so his job was predicting the weather in the US. That's a pretty important job. And he said when he was working on his models, he was only able to create 2 or maybe 3 layer models, which is a pretty, at the time, the reason he couldn't have more layers in his models was because it was just too expensive. Because the compute he would have to go, rent from the local university. And so he didn't have budget for it. So they got good models, but not great models. The prediction was not fantastic. Today, you'll have a 200-layer model, 150-layer model to look at a picture of a cat. It's just, you can do that. It's just really, really cheap. So the first thing is compute. Yes?
It's okay to ask a question?
Sure. Yeah.
Do you have any opinion about, for example, if FPGA would be better than the TPU for some use cases?
I think it's still way early in the game to know for sure. I mean, the TPUs we built, specifically for TensorFlow for the use cases of our internal use cases. I think that we are really optimistic about the performance of them, and at the end of the day, it just means it's going to cost less, right, to do your training. So yeah, we think that TensorFlow TPUs are going to be.
The thing is that maybe now Tensor is the main thing, and maybe in the future will be something else. So the FPGA can change itself while the TPU is less adaptable for that. So.
Yeah, I think it's fair. I think again, it comes down to how much effort it takes to change your models, and what's the cost. It's sad to say, but it's true, right? It comes down to dollars and cents or calculation. But that was a very long way of saying it's cheaper to do the compute, and that's the first thing you need. Second thing is you need data, and I probably don't need to spend a lot of time on this. We have data now, right? We never used to have, or we've had data, but now we have a lot of data, right? Everybody carries these things around, and we're collecting IoT data, sensor data. We have an incredible corpus of data that we had never had before that's being collected. So that's the second thing that's changed. Third is just better algorithms, and this is more of an ML wonky kind of thing. I mean, we've gotten better at doing things like thank you. Looking at how natural intelligence is determined or is created, and guys like Jeff Hinton out of the University of Toronto have applied that to artificial intelligence. And so looking at the brain and understanding how the brain rewards itself, and this is some of the developments in around the models in deep learning and neural nets. So we've just made some progress, and I honestly believe the reason we made progress is because of the development of the first two things, right? We've got cheaper compute, and we've got more and more data. So those are the three things that kind of fall into why now. It's cheap compute, it's lots and lots of data, and it's better algorithms. So I promised I wouldn't talk too long and just make myself available for you. I will talk a little bit about how we do machine learning and what's coming around the corner. So for us, we've committed all in, I mean all in, on machine learning. If you look, when I joined the company 5 years ago, the focus was making the transition from desktop to mobile. Right, this is the #1 strategic initiative for Google. I think we successfully made that transition. And then about 3 years ago, the transition is to to developing better machine learning models. We've seen the potential through a few early wins in things like search and translation. We've seen the potential with DeepMind. DeepMind, a company we acquired 2 years ago. They have some great simulations showing how games can learn. You create models to learn to win in games, and looking at that and seeing how well we can apply that to our 7 products of 1 billion users. So we are all in. We have now over 4,000 models deployed internally across our product portfolio. So this is now how we develop software. Our developers go through anywhere from 2 weeks to 6 months of additional training to know how and when to use ML in their products. We've got the Google Brain team, we've got the DeepMind team, and now we've got, and then we've got research, and we've got applied, and we've got the offerings through our cloud group, which is where I work, which takes a lot of these breakthroughs, these developments, and make them available for anybody to use. There's no shortage of examples of how we use machine learning internally. So search, rank brain is a machine learning model that is now the number 3 signal, I think it is, for search out of 150 signals. And it's the biggest improvement in the last 2 years in our search results. YouTube, watch next, it makes recommendations on which videos you watch next, has been fantastic. Google Translate, right? We've been doing that for years. We think we were pretty good at it, and then we applied a machine learning model, and we're able to go from something like a 96-point-something% accuracy to a 98-point-something accuracy of translations. Even internally. So we thought, we spent $27 billion on our own data centers over the last 3 years. So, we spent a lot of money on our own data centers, and we think we're pretty good at managing, our 100+ data centers. It's the core to our business. So what we did was we took a machine learning model, right? Remember, machine learning is basically taking examples and making predictions, and we fed it the data that we had on cooling of these data centers. To see if we can create a model that controlled the cooling of the data centers better than we ourselves knew how to. And sure enough, it did. We turned it on. We saved up to 40% on the data center, and we turned it on. And for a company like us, that is a lot of money, a lot of money saved. So even internally, in something as pedantic as running our data centers, we've applied machine learning to. Just down the list of just about everything you can think of, from self-driving cars, through the services that you use, maps. We have a machine learning model built, 4,000 deployed internally. I guess the last thing I'll talk about briefly is our portfolio, and because I think the title of this is sort of what's next, or the future of AI ML. So we've taken. When we first started looking at how machine learning can be used internally, we had to do a bunch of things so that us being Google, we're a bunch of software developers, not ML scientists. We have a bunch of ML scientists, especially now that we acquired DeepMind and made a big investment in this area. We've hired lots of them. In fact, I think 4 of the top 10, thinkers in machine learning are in some way affiliated with Google, according to Time magazine or something. But we realized that we needed to make it accessible, easy for the software developer who knows how to, develop in Python, how they can go and include machine learning in their products. And so we went and developed a set of libraries and tools, and made it such that our developers can use machine learning models in a relatively simple way without having to go back to school for 7 years to get their PhD. So that set of libraries and tools we took, and in October of 2015, we open sourced them, and that is now TensorFlow. So TensorFlow has taken the world by storm. I think it's got something like 75,000 GitHub stars. We're the next closest open source machine learning set of libraries has like 5,000 or 8,000 or something like that. It's not like that. So my one point of advice always is, if you have one thing to walk away from here, is go play with TensorFlow. It's free. It's lots of training. It's a great community that's developed. It's kind of it's been a bit of a whirlwind, and I think that that's an area that if you want to get started in it, it's a good starting point. So going back to the third piece, what does Google do? TensorFlow is one, so we open sourced it, we support it actively, we've got a broad community support for it, we contribute regularly. The annual TensorFlow Summit, the second annual TensorFlow Summit is next week in Mountain View. We had something like 5,000 people apply to attend. There's only 400 or 500 spaces. So open source TensorFlow, one thing we invest in and contribute to. On the other side, so you still need to know a fair amount of machine learning. You don't have to be an expert at it, but you have to go through some training. It's designed for developers. Then the other side, we've got a set of pre-trained models that you don't have to know anything about machine learning. You literally can just call them with a simple set of API calls, and we return a JSON.
Sorry, you're just talking so loud.
I'll talk louder. So yeah, you can make those API calls, and so these are pre-trained models. Remember, machine learning models are using examples to make predictions, and so we have lots of examples. Examples are data. We happen to have lots of customer data, so we've gone and pre-trained these models for things like what we call perception services, seeing, hearing, and understanding the world. So we have a vision API that looks at pictures and can identify the objects in pictures. You can use it simply through a set of API calls. We have video API, which is something that's really unique. It's the same type of thing. You send some videos up, and it processes them, comes back and tells you what's in the videos. We have translation. We have speech, which is speech to text. We've got something called natural language understanding. So rather than just understanding, not just taking the speech to text, but also then understanding the sentiment of what's happening in the text. So a set of APIs. Yes.
I heard that we have a style API. If you know about this, if you can say that you want.
A style API?
Yeah.
Style transfer.
Oh, style transfer? Is that what you're talking about? Yeah, that's an experiment, one of the AI experiments. So we've that's intended to demonstrate what machine learning can do. It's kind of a fun thing, but it's based on the same structure that I just mentioned. It's just not a commercially available product that somebody would usually plug into their system, their software. So let me finish, because I think I've taken way longer than I expected to. Say we also have so we have these pre-trained set of APIs. They're so super simple to use, simple API calls. We've got TensorFlow inside, and in between we've got the ability for you to take your model, perhaps that you've developed on your own Jupyter laptop at home, a TensorFlow model, and to do the training of it at scale on our cloud, so on our infrastructure. So you don't need to build and manage clusters. Pay for only what you use. All the song and dance you typically get from a cloud pitch. So in the middle we've got, it's called CMLE. It's a cloud machine learning engine. Again, that's a train where you can do training at scale. You use our infrastructure, you use our network. You can even send predictions out to endpoints, all managed by us. And then we just came out with, and this is what I initially was going to talk about, something called AutoML. But I didn't want to jump in and talk about AutoML because A would be like a product pitch, and B, without even giving the context of sort of why ML and AI is really important to Google and how we work with it. But AutoML is, the concept is, there are 20 million developers in the world, 7 billion people, and maybe a million people who know data science, maybe. And so the biggest bottleneck for developing machine learning is you don't have the skill set, the quality people who can go out and do it. And so what we've done is taken these canned pre-trained models and made them, we will make them available. AutoML, the very first one we've done is vision, make them available in a very simple UI so that an analyst can use the pre-trained models and customize them to their own use case. So in the case of images, vision, what we call vision, you can, you really just retrain the last layer with your own images and your own labels, your own features, your own labels. And so it's a simple UI where you go in and upload your images, put the labels in. You say about 100 examples or so, and you can start to get insights so that when you send new ones over, you've then trained the model to be able to identify that specific use case. The idea is we're trying to make it as simple as possible for people to use their own data and still get some valid, interesting, relevant results. So AutoML, auto machine learning, we announced 4 months ago, thereabouts. But all of our pre-trained APIs, so you'll see two things. One is you'll see more and more of these pre-trained APIs we're going to make available. Again, because we're lucky, we have all this data. We'll be able to make those available to people. But also the existing pre-trained APIs, the perception APIs, we're going to make customizable through AutoML. Today it's just AutoML Vision. In the future it'll be AutoML Video and others. Yes?
Technical question. It sounded, when you just made reference to AutoML, it sounded as if you were saying that you have a pre-trained network and then you add an additional layer as sort of blank layer and allow the client then to train based on the initial structure, the new layer. Is that technically?
That's sort of it. Yeah, it's transfer learning on the last layer.
So it's appending a layer.
Yeah. So we're using the ImageNet database for the model that's trained, and then for images, and then we're adding the last layer, which is what the customer themselves have implemented. Now, to them, of course, it's completely seamless, right? They just see a very easy, usable UI where you take images, you upload them, you put labels in. It does come back and give you some data on it that you can interpret so that you can give the model better images. But generally speaking, we try to make it as simple as possible and sort of abstract away that level. Because if somebody wants to do transfer learning, they can do it perfectly fine today with TensorFlow. You have to know a little bit about TensorFlow.
So the pre-trained stack before the addition of the additional layer is static.
Yes, exactly. That's exactly, and that's the quote problem that AutoML solves. Yeah. So let me summarize, and then I stick around as long as you guys want. Machine learning, using examples, make predictions. Google's gone all in on machine learning. We have a whole set of services that we've been able to benefit from. We've got some investments and some services externally that you can take advantage of as a developer, and it's going to be an exciting few years. I guess I'll finish with the last question is people ask what's the future, and if you asked me a few years ago, it was, hey, ML is going to be in everything, right? It's going to really make software better, and that was maybe 2 or 3 years ago is what I think I talked about a lot. And then in the last couple of years, it's really been, hey, the real challenge or the forefront of developing successful ML it's really about getting your arms around the data, right? In other words, it's 80% of what you do is data wrangling, and making ways to get data and manage that data and make it accessible and all that good stuff. I think over the next couple of years, or at least maybe today, a lot of the conversations in the circles are around making it practical, like what we're doing with AutoML. But there's a lot of discussions and chat and arguments about how practical really is machine learning. Are you getting those tangible results? Is it something that's being deployed in sort of regular environments? I think that's where sort of making machine learning easy, making machine learning accessible. That's sort of, I think, where the conversations are happening today. So with that, I will stick around and happy to chat. And I think, who else do we have here from Google? Is it just, oh, okay. We have two people from Google. So feel free to corner them. And
both of us.
and of course, these gentlemen here, your lovely host, you can corner them. And I'll be around, and I'm going to take my coat off.
Questions?
Yeah, questions? You want to do it in a group, or you want to?
Firstly, Google do effort to make machine learning experts unemployed before taxi drivers.
What's that?
So with AutoML in this kind of directions, Google tried to make machine learning experts unemployed before taxi drivers.
We're trying to make machine learning experts
No,
unemployed?
no, but that's what it's job.
Yeah.
But actually, when you talk about AutoML or more general, it's in a way it's trying to expand the boundaries to more generalized AI kind of approach, right? In a way, does first fix me if I'm wrong about this, or I'm interested to hear about Google effort in these directions. And do Google use the data that supplied by the one that use the system, this one or others, all their models to incorporate in their own systems?
So the second one's a pretty easy answer, no. If anybody uses our infrastructure, it's their data. We don't. We don't do anything with it. We're contractually prevented from doing it, and we can be sued. We got deep pockets. We can be sued for a lot of money. If we were breached that, also the data itself, you can keep it encrypted. You can manage the keys yourself. So even if somebody wanted to do that, we couldn't. But the first one was, so talk about generalized AI. That's solving for general artificial intelligence is sort of a term, right? And that we are working on that. That's what the DeepMind guys, that's their entire focus, is not solving for specific AI, not specific intelligence. It's more general intelligence, which is a really, really hard and pretty exciting problem to solve. So specific artificial intelligence is, I can win in chess, right? I've created a system that can win in chess. General artificial intelligence is, I created a system that can win in strategy games, right? And you can apply it against a whole set of strategy games, and that same system is smart. And we've done that now. That's why we've seen the benefits in translation, for instance. The generalized system that can translate two pairs, and it doesn't matter what the two pairs are, and it's super efficient. So big picture is, yeah, we have people who are working on trying to solve for general artificial intelligence, but AutoML is really trying to bring machine learning into the mainstream a little bit more. So that, again, I think of the analyst, not even the developer, but the analyst who's trying to get results. So you've got developer, you've got the analyst, you've got data scientist, and sort of each of those three now has a way to work with machine learning.
Is this AutoML concatenation technology, is this embedded now in the newest releases of TensorFlow?
It's not. It's not. This is a specific
libraries.
This is a specific differentiated commercial offering. So made available service through our public cloud group. So it's a fee-for-service offering that generally enterprises would use directly themselves, as opposed to perhaps our APIs, which a developer might plug into directly as part of their application. This might actually be used by an analyst in a firm.
So it's not open source?
It's not open source, no. AutoML is not. TensorFlow is, and some of the commercial, the cloud machine learning engine is not. And there's a whole, I didn't talk about the whole set of cloud offerings we offer, because I didn't want to make this a sales pitch, but we've got cloud storage, cloud compute, you've got networking, the data storage and analytics, BigQuery, and a whole host of other things. Yes?
I think that Google are very generous by publishing papers. And you asked about if it's open source. So I think you can see many papers by Google of the AutoML.
Oh yeah, our data blog, we've got two blogs that are really, really good, and I couldn't have said this a year ago even. But one is our Google, was it google.cloud.com slash, I'm looking back here, data, right? That's the data blog, and every couple days we've got some really neat thing you can look at. And then we also have the Brain team, which truly does research and publishes really interesting papers.
Well, I've noticed working with TensorFlow that it's possible to manipulate individual functions. It's possible to manipulate individual operations. But to have it, and I guess what Google has done now is that it's made it more of a systematic, it's regulated it in a way, it made it more of an API, or it's an in-house API. But it's still possible. I mean, it's a concept that I'm sure I'm not the only person who's thought of and has thought about going that direction. I mean, obviously you've done it, and I'm sure other people have done it too. But it's possible to achieve with TensorFlow as it is. With
Yeah.
some modifications.
Right, well, that's the thing, TensorFlow, you need to know a little bit about TensorFlow. And the idea of AutoML is that you can still take advantage of pre-trained models, but you can actually customize it a little bit.
When would it be available? When it's still in alpha?
For preview. It's actually not in alpha. It's in the very sorry, but I'm waiting.
Okay, sure, I'm waiting.
But
I see. We are racing as quickly as we can to make it available to as many people as we possibly can. Is the camera still on? Yeah, we were pleasantly surprised by the level of interest in vision, AutoML vision. And that's a justification, not justification, it's a validation for that model of sort of in between, right? TensorFlow on one side, canned APIs on the other, something in between that lets you take advantage of both. Coming soon. Working very hard to make it available.
Do you think it will be open source, the work that's done with
I don't know. I'm just speculating here. I don't think so, because it's a service more than anything else, versus a set of libraries and tools. So I don't think it will be. It's not to say that somebody couldn't go out and deliver something similar as you discussed themselves, but I don't think AutoML will. Yeah, it'll be interesting. There's a TensorFlow community which is really independent now. I mean, we're huge contributors to it. We fund it and have teams that contribute to it, but TensorFlow is its own animal.
How branded is TensorFlow? How Google branded is it? How is it? Does it make calls to Google URLs in the process of using it? I mean, how integrated is it? I have to be honest, I haven't dissected the entire.
Yeah, why don't we talk one-on-one, and I'll go a little deeper into TensorFlow. I think it came from Google, but we're trying to make it a community of people who can contribute to it and use it, just as we did with as we've done with Kubernetes and a whole host of things prior to this.
But using it completely independent of Google servers or any kind of Google calls, and without even being noticed by Google in any way, to use TensorFlow is completely independent.
Yeah. I mean,
Easily, it doesn't have to be modified.
One could argue that one of the larger larger use cases of TensorFlow is not on our platform.
We get a question a lot about the possibility to export models after them being trained with the custom data that the customer provide. If you can after that take the model and export that.
Using AutoML?
Yeah, after trained by the AutoML.
Yeah, that's not something that's not kind of the designed use case. Although I'd love to hear more about questions you could ask.
Doesn't make sense to do this. Eventually you're going to expose something which is based
the
on
original, right?
So I don't think that Google is going to expose their own models, even with the last layer. So
Yeah, but the argument gonna be the same like with the managed service or not. So you have a model and that's it, or you have a full service that you can just.
It is an interesting use case because I think there's a huge demand for a marketplace for models,
Yeah.
right? And I think that if you spend any time on Kaggle, that's the, there's an interesting community now of over 1 million data scientists that are, gathering, competing, doing, collaborations on Kaggle. And I think that, and I don't work in the Kaggle group, but I can see that at some point being a part of that offering is the ability for you to have exchanges or in and around models in that community.
cool.
More questions? More questions? Questions? Yes.
Can you please give an estimate of how many current researchers are currently working on the AutoML project?
How many?
How many data scientists at Google or machine learning researchers?
So we're like curious about the amount of their impact, right? If 9 are going to throw 1 million, throw to the, to be a taxi driver and then.
Wait, there's two questions there. So what's the level of commitment for AutoML as a sort of product at Google is one question, and then your question is are we going to put data scientists out of work?
No, we're trying to see the impact of those 9 people. I'm just kidding, you said on the world. So they 9 people doing a job for 1 million.
Yeah, it's probably it's definitely more than 9 people. I'll just say, generally speaking, we have significantly funded machine learning at Google. We've hired a lot of people, and we continue to hire a lot of people. And that's actually one of the reasons we came out with AutoML, is that you can't hire enough people. It's just, there's not enough good data scientists. And so we are, trying to find ways to shortcut to get the same benefits of it. There's a lot of people working on it. There's a lot of people working on the entire ML, but it's still not enough, right? And I think if you talk to anybody at Facebook or Amazon or Microsoft or the long list of companies, they would say the same thing, right? Probably yourselves, right? You can't find enough really good people who know this stuff.
Can you tell us about what's going to be next after Vision, so we know what to expect? But what's next?
Yeah, I can't, especially with the camera rolling now. But we've stated that AutoML is a it's a pun intended. It's a vision for making these canned APIs more available. And we only have six APIs available, and we'll have more as time goes by. And of those 6, we'll continue down the path. There's a lot of interest in, especially things like text and natural language processing, because there's such distinct words and phrases and sentiment by industry, by your specific use cases. A lot of interest there, and then I personally have a lot of affinity towards the video one because I think it's magic. It's crazy. You can take 100 million hours of video and upload it, and then it'll come back and tell you what's in those videos. And so I personally really am excited about that one. So it's a lot of interest, and it's coming.
Okay.
Is there some additional packages that have been developed by Google that are also open source that provide better user interface to more accessible user interface for TensorFlow?
Yes.
Yeah.
Was something specifically that was developed by Google as well?
It's I think it's a community developed by people in the academy, as I know. Developed, very few. And the people.
There's a TensorFlow RT and there's TensorFlow Lite. There's many things around there. You can check out. Probably more than 10 stuff by Google related to that.
And there's things that, big UIs like TensorBoard, and also I'd say that we are working hard to it's a fine line, because it has to be a robust and flexible system, right? That the data scientists can use. That can be customized. That's horizontally scalable. That's a real data science tool. At the same time, we are trying to help developers be able to actually use data science, so it has to adhere to for the requirements of a developer, but then also we want, everybody wants it to be easy to use. And those things are, multi-dimensional chess, trying to figure out the right way to. And remember, TensorFlow is open source, so we don't, we contribute, but we contribute in these areas and those areas, and we're hoping other people contribute in these areas and the other areas. If that makes sense.
Little corporate question, you said before that you're all in on machine learning. So in terms of R&D, in terms of the percentage of R&D, what would you say that is?
I can't disclose that. But I mean, it'd be harder to answer the question of what portion of R&D doesn't do something in machine learning. Because like I said, even our sort of normal Python developers have gone through and been trained in this stuff. Good. Good.
Yeah.
All right.
What is your background? Where are you coming from?
My background?
Yeah.
So my degree was in actually applied math, so I'm a math guy.
Okay.
And then I worked in software, and then flipped back and forth between hardware companies and Sun Microsystems for a while. And kind of grew up in the software space and hardware space around stored machine data and machine learning. Last 2 years or so, it's been almost maybe 18 months, it's been almost exclusively now machine learning.
Okay.
But math is a really good underpinning for all this stuff.
Yeah.
Math is the future. All right,
Yeah.
I'll be here for a while.
Thank you.